Welcome to my channel. I'm Zhang Xu. Let's look at the problem 51 in chapter 15. Chapter 15 is about waves. So we can see first one, we have the standing wave on a chord of length L, and leader density is given, and then the Ft tension is given, and we need to prove the frequency in this function, right? N is an integral. So first one, we consider the standing wave on one chord, and the length is L fixed at both ends. So the standing wave's wavelength is in this function. Do you agree? Yes. This is we learned in previous in this chapter in textbook. And also we have another way to find the wavelength, right? We know the wavelength can be written as the velocity times the period. Agree? Yes. Now the period is 1/f. Do you agree? So this is n knots. So wavelength lambda n is 2L divided by n. So lambda n also equal to V times Tn and then V/Fn. So this part we have. Now we need to connect it with the fundamental wavelength, the fundamental frequency. Agree? So fundamental frequency, how can we do that? We use Fn/F1 equal to lambda 1 divided by lambda n. Because from this equation we can get velocity is constant, so lambda n is proportional to 1/Fn, right? So this one we can get this function. And there, look at there, the lambda 1/lambda n is just n. So from this equation we get the relationship between Fn and F1. So we can see Fn equal to n times the fundamental frequency. Agree? So now Fn we need to find is F1. So now the next step, look at F1. So how can we do that? We know F1 is a velocity over lambda 1. Lambda 1 is easy, right? Lambda 1 is just a 2L. Next step is to look at the V. And this one we know the tension and the leader density. So V is easy in this function, squared Ft/mu. So we input the V inside and lambda 1 2L, and then we get a function for lambda 1. Look like this one. Agree? Now input lambda 1 in this function, we get this Fn, look like this one. Exactly. So in this one, we can see for the n knots frequency just equal to this function. N is an integral. Thank you.